Hello, my name is Marta Santos and I work as Operations Manager at ClearDetections, focusing on bringing you solutions for plant health diagnostics. In this video, I will show you how to use our real-time PCR diagnostic kits for plant pathogenic nematodes participating on Valley Test training session. We will use our Melodogena sheetwoodi and Bursophilencus xylophilus diagnostic kit coupled with our general nematode diagnostic kit for external control. However, you can take this approach for any of our plant pathogenic nematodes diagnostic kits, which you can find in the link in the description box. Our kit contains the user manual and the reagents to analyze our species. In this instruction video, we will use already purified DNA from infected and non-infected samples. If you want to know more about how to extract DNA from nematode samples, check the link on the description box for our nematode DNA extraction and purification kits. If you need more information on how to properly process your samples before diagnostics, we suggest you to check EPO Diagnosis database of expertise or to contact us directly. In these experiments, we will use 3 already purified DNA samples: a non-infected sample, a Melodogena sheetwoodi infected sample, and a Melodogena falix infected sample. We usually advise to dilute the DNA 10 to 20-fold to avoid inhibition of the PCR reaction. But of course, this is dependent on the DNA extraction method you used. Dilution of the DNA will avoid PCR reaction inhibition due to the presence of impurities in your DNA sample. Remember to not dilute previously diluted samples. For every kit, repeat the following steps. First, we prepare the PCR mix by gently tapping the vial to make sure that the content is at the bottom. Open the lid, remove and discard the tap, and add 680 microliters of resuspension buffer. Close the vial and incubate for 5 minutes before proceeding to the next steps. Then add 105 microliters of the correspondent primer set and mark the vial once the primer set is added. To prepare the positive amplification control, centrifuge the tube to make sure the content is at the bottom. Then open the lid and add 300 microliters of resuspension buffer. Close the tube, mix by vortexing and incubate for 5 minutes before proceeding to the next steps. Now we have prepared the DNA, the puck, and the PCR mix including primers. If you're using also our Bursophilencus xylophilus kit, just repeat these steps for its samples. We can proceed to the real-time PCR reaction. First, we design the layout of the experiment as shown in the table. On each DNA sample, we will perform a real-time PCR targeting Melodogena sheetwoodi. We will also include primers to detect general nematodes to use as external control of the DNA extraction. We advise to analyze your samples at least in duplo if you have previous experience in qPCR, or in triple if you're not yet familiarized with real-time PCR techniques. In this experiment, we will include the 3 samples: a non-infected, Melodogena sheetwoodi and a Melodogena falix infected sample. We will also include the positive control and the negative control for each PCR mix. Pipette 15 microliters of the PCR mix in their designated wells as planned in the table. Briefly vortex and spin down the pucks. Then pipette 5 microliters in their designated well. Be very careful not to contaminate neighboring wells. Pipette 5 microliters of the nuclease-free water in the negative amplification control wells. Be very careful not to contaminate neighboring wells. Pipette 5 microliters of each DNA sample in their designated wells. Be very careful not to contaminate neighboring wells. Now all reagents are in the plate and the content of each well should be 20 microliters. Now we will place the plate seal. Be careful not to leave fingerprints on the seal. If you're using as well our Bursophilencus Chilophilus kits, proceed the same for its samples. Briefly centrifuge your plate to make sure the content is at the bottom and free of bubbles. Place the plate in the real-time PCR machine and start the program. Make sure to give the correct instruction for the program and select the FAM fluorescent channel. The reaction starts with 3 minutes of enzyme activation at 95 degrees, followed by 35 cycles, DNA denaturation 95 degrees for 10 seconds, primer annealing at 63 degrees for 60 seconds, and primer extension of 72 degrees for 30 seconds. Finally, the melt curve is measured by recording the DNA denaturation between the temperatures of 72 to 95 degrees. The first step in data analysis is analyzing the controls for the general nematode primers. Here we see the amplification curves of the PAC and the NAC for the general nematode. The NAC is clearly negative. This shows that the real-time PCR was successful. Analysis of the amplification curve should always be complemented with the analysis of the melting curve. Here we see the melting curves of the PAC and the NAC for the detection of the general nematode. Multiple peaks might be found for general nematode. This confirms that the real-time PCR was successful. The second step is to analyze if the extraction of the DNA from the samples was successful. Here we see the amplification curves of the 3 samples for the detection of the general nematode. This shows that the DNA extraction and the real-time PCR were successful for the 3 samples. We should not analyze the melting curve of the general nematode of real samples. Now we conclude that the DNA extraction and the real-time PCR of general nematode were successful. We can continue to analyze the results of our target species. First, we analyze the controls for the detection of Melanogyne sheetwoodi. Here we see the amplification curves of the PAC for Melanogyne sheetwoodi. The NAC is clearly negative. This shows that the real-time PCR was successful. Now we continue with the samples. Here we see the amplification curves only existent for sample 2. In sample 1 and sample 3, no Melanogyne sheetwoodi was detected. Here we see the melting curves for the sample of Melanogyne sheetwoodi, the same peak as the PAC. If you're analyzing samples with our Bursophilencus Chilophilus kit, apply the same methodology to analyze your results. This was our instruction video on how to use our real-time PCR diagnostic kit for nematodes. Thank you for watching. If you have any questions or suggestions, we invite you to visit our website or to contact us directly via email.